Hey, Mr. Harrod, I'm here. We're going to continue with doing our empirical formulas and molecular formula problems here. Here we go. Here's another empirical formula here. What is empirical formula of the compound? Remember, we have to do percent to mass, mass to moles, divide by smallest, multiply till whole. Okay, here we go. So we have a compound that has carbon, hydrogen, and oxygen. So we are going to start off with 94.74 grams of carbon. We are going to have 21.05 grams of hydrogen. Hey, did I tell you if you don't write down these steps, I'm going to mark it wrong? Yeah, because I have no clue what you're doing. And neither do you. 84.21 grams of oxygen, right? Step 1, percent the mass. Done. Double check to make sure those numbers add up to 200. They do. Then we're going to divide by the molar mass. Molar mass of carbon is 12.01. Molar mass of hydrogen is 1.01. Molar mass of oxygen is 16.00. And we're going to get some moles. Okay. Again, we're not going to write out a big, long number here. 94.7 divided by 12.01. So this time we got 7.888426 carbons. 20.841584 hydrogens. I gotta copy the number right. 263125. This is the moles of oxygen. This is the moles of hydrogen. This is the moles of carbon. Okay. Gonna divide by the smallest, which would be 5.263125 divided by 5.263125 divided by 5.263125. So this one here, we get 1 oxygen. All right. Here I get 3.96. That's close enough to 4 hydrogens. But here, I get 1.49. 1.49? I have to round that one to 1.5. Carbons. So if I was to write the formula right now, you would write down C1.5H4O. Nobody does that. No one does that. That's why we got to multiply these to the whole. Since this is a 0.5, I know I'm going to multiply by 2. If it was 0.33, multiply by 3. If it was 0.25 or 0.75, I multiply by 4. So we're going to multiply these by 2. So we're going to get 3 C's, 8 H's, and 2 oxys. This is what people do, so it's C3H8O2. That is the correct answer. Okay. Determining molecular formula. Step for solving molecular formula problems here. Find the molar mass of the empirical formula. Step 1. Step 2. Find the molar mass of the molecular formula. Step 3, get a ratio. That is how you do these problems. Okay? Do it a little differently, but we'll see here. Okay. So, step 1 here. If the empirical formula of a carbohydrate CHO and its molecular mass is known to be 240, what is the molecular formula of the carbohydrate? Okay. Step 1. Find molar mass of the molecule. That's easily done. It's already listed. 240 grams per mole. Step 2. Find molar mass of empirical. Okay. So luckily, we have the empirical formula here as CHO. So we're going to do CH and O. We got 1, we got 2, we got 1. 1 times 12.01 is 12.01. 2 times 1.01 is 2.02. And 1 times 16.00 is 16.00. 30.03 grams per mole. That is the empirical molar mass. Okay? So I know that is 30.03 grams per mole. Okay. Step 3. Find ratio. So the ratio here is going to be 240 G/moles divided by 30.03 G/moles. That comes out to 8. So the ratio here is 8. Last step, multiply empirical formula by ratio, which leads us to C8H16O8. You can check this too by finding the molar mass of this and seeing if it's 240. Then doing 8 times 12.01, 16 times 1.01, and 8 times 16. And you can double check it that way. Okay. Okay, here is the fun problem here. Dun 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 dun. Dun 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 dun. Dun 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 dun. It's the fun one. Sorry, I haven't put much sounds in these videos because I have to get them done like right away. You know, I don't have time to sit down and make the videos fun and noisy and yeah. So step 1, find molar mass molecular. That's easy. It's listed. 78 grams per mole. Okay. Then we have to find the molar mass of empirical. There's a problem. We don't even know what the empirical formula is. So that's why we have to do this. Percent to mass. Mass to moles. Divide by smallest. Multiply till whole. Okay. So we have to do basically this thing first to find the formula, so then we can find the molar mass, so then we can do the ratio. Yeah. Okay. So, hydrocarbon contains only carbon and hydrogen. Okay? So, if it is, carbon is 92.3 grams of carbon, I know the percentages have to add up to 100, so I know that there is 7.7 grams of hydrogen. This one's carbon. Okay. So now we are going to divide by the molar mass, which is 12.01. Okay, so we get 7.68526. Why am I dividing by 12.01 here? It's 1.01, Mr. Herodom. 1.01, Mr. Herodom, with more math heart. Come on, Mr. Herodom. And I get 7.62376 on this one. So you divide by the smallest here, 7.6237. Divide by 7.6237. Here we get 1 hydrogen. When you actually divide these numbers here, get 1.008. That's close enough to 1. So we get 1 carbon. So I know my empirical formula is CH. Molar mass of empirical would be 13.02 grams per mole, right? 12.01 plus 1.01. So this is 13.02 grams per mole. Okay, next thing we're going to do is find ratio. So we have to do ratio equals 78 divided by 13.02, 6. So then we multiply empirical formula by ratio, and we end up getting C6H6 is our correct answer. And you can double check it by seeing if it has a molar mass of 78, which it does. Remember, this is actually benzene, best way to decaffeinate coffee. Also causes cancer though, so they don't do that anymore. Okay, you guys are champions. The legend is out.